Now let's start to turn our attention towards subtraction. We know that subtraction is the opposite of addition. They're both additive operations, and so they're very related. For example, we know that we can use the missing addend model to solve a subtraction problem. And so that's actually something that we will use even when we're practicing with new algorithms. First, we'll start with the concrete model. That's the model that uses the base 10 blocks. So if I wanted to represent the subtraction between the numbers 243 and 61, what I would first do is represent 243 using base 10 blocks. 2 flats to represent the 200, and then we would show 4 longs to represent the 4 in the tens place, and then 3 units to represent the 3 in the ones place. Next, I'm going to attempt to take away the value of 61. That would say I need to remove 6 longs and 1 single. Now, it's possible for me to take away 1 single right now, but there are only 4 longs for me to play with. But instead of giving up and saying, oh, I don't know what to do, we will simply break open one of the flats to create enough longs for us to borrow or to take away. So if I crack open one of those flats, I generate 10 longs. 10 longs. And that is in addition to the 4 longs that were already there. So now I'm going to subtract 6 of those longs and 1 single. That would leave me behind 1 flat, 8 longs, 2 singles. Now this is the concrete model, and we're going to use this idea to help understand the other models for subtraction. And really, subtraction can be modeled using any one of the addition algorithms combined with the missing addend idea. But when it comes to the standard algorithm, we really have to understand this concept of regrouping. Now, it used to be referred to as borrowing, but that's not a great word to use. And the reason for that is if you go to the bank and you ask if you can borrow some money, they're not doing an exchange of 10 $1 bills for a $10 bill. When you borrow money from the bank, you are acquiring more money than you started with. In this example, when we broke open the flat, we did not gain more value, we just simply represented it differently. So instead of using the word borrow, we're going to use the word regroup. If I wanted to use the standard subtraction algorithm, I would stack my numbers vertically. I would start in the ones column, 3 minus 1, no problem. If I have 3 things, I can easily take one of them away, leaving behind 2. 4 minus 6, however, if I only have 4 things, I cannot take 6 away from that. So we need to regroup. We're going to look to our larger place value neighbor. This neighbor has 2 in its place value. So we're going to let the neighbor keep one of them. And then we're going to regroup and put one of those flats, essentially, into our longs column. That says that we have 10 plus 4, in other words, 14. 14 minus 6 would leave us with 8. And then lastly, we bring down the 1 in the hundreds column for 182. So this idea of regrouping can be visualized using the concrete model, and then it helps us understand how it works in the standard algorithm. One new algorithm for subtraction is called the Equal-Addends Algorithm. This uses the fact that if we were to look at a number line, for example, and look at the numbers 2 and 7, they're exactly 5 units apart. And if I were to move 2 and 7 down the number line by, say, 1 unit, that would move me 3 and 8. I moved each number down 1, but the space between them didn't change. That's what the Equal-Addends algorithm takes into mind. This is really nice because it will eliminate the need for borrowing, aka regrouping. For example, when we look at 255 minus 163, we can see that in the tens column we would have to regroup. Or we use the Equal-Addends algorithm, which says add numbers to change the subtraction number into a number that has a bunch of zeros behind it. Looking at 163, I can tell that adding 7 to this number will earn a 0 in the units place of that number. So if I add 7 to 163, that becomes 170. But remember, if I'm adding it to the bottom number, I need to also add it to the top. So adding 7 to 255 turns that into 262. Now, the original problem was 255 minus 163. That problem will have the same answer as 262 minus 170. But notice we still haven't eliminated the need for regrouping in the tens column. So we need to add another number to turn the tens digit into a 0. We know 7 plus 3 is 10. So if we add 30 to 70, we will end up with a 0 in the tens place. So adding 30 to 170 turns our subtrahend, the number we're subtracting, into 200. And if we add 30 to 170, we need to add 30 to 262 as well. So our new problem looks like 292 minus 200, and that will have the same answer as the rest. And if you're not convinced of that, try doing each problem individually. 255 minus 163, 262 minus 170, 292 minus 200, they're all equal to 92, but only this last one requires no regrouping. So it's a nice trick that will help you do subtraction without ever having to borrow, or what we are calling regroup. One last model for subtraction is the counting up model. Now, you've probably seen this talked about because it's used in Common Core. So I want to show you how it works. If I want to do the subtraction 255 minus 163, I start at the number that I'm subtracting, and then I count up until I get to the number that I'm starting at, 255. So I want to know how far apart are these numbers. That's what subtraction is asking. And since the real question is how far apart are these numbers, using this model really helps illustrate what we mean when we say how far apart the numbers are. So if I add 7 to 163, we already know we get 170. And if I add 30 to 170, we already know we get 200. And then if I add 55 to 200, I get 255. The distance, or the difference, or the subtraction of these numbers is all of the space in between. So we have 7 units here, 30 units here, and 55 units here. If we add those together, we get 92 units. They are 92 units apart. Notice this is the same subtraction that we did using the Equal-Addends. It looks a little bit different, but also there's a few things that are similar here. But the most important part is that no matter which method we use to calculate this subtraction, we get the same answer.